Hi everyone. In today's lesson, we are going to be covering different mathematical functions and predefined constants, as well as adding comments to your code. First, let's talk about adding comments to code. Comments are anything that you don't want to be a part of your code. So for example, if I put 3 plus 4, but I want to explain what 3 plus 4 is doing to somebody who is looking at my code, I put a % symbol, and then I can type anything I want, and MATLAB will change the color to green. So I can say this is an addition statement of 3 plus 4, or anything else I want, and it will be in green. That means MATLAB will not execute it as part of the code. So if I hit enter, I get 7, and this just stays as a comment. The other thing I want to talk about are two useful commands that can pull up a full list of elementary and special functions. We have help elfun, so it pulls up all of these different trig functions, exponential functions, complex functions, and rounding and remainder functions. And it explains what each of these do. I won't go through all of these today, but I will talk about some of these later on. And we have help specfun. And these are specialized mathematical functions, which you may not even have heard of. Or need to ever use. I haven't used even half of these before. But using help elfun, and L stands for elementary, and fun is for function, and then help specfun, spec is specialized, and fun is function. So this will give you an inclusive list of all the elementary and specialized functions in MATLAB. So all of these are built-in functions, but let's go through some of the more common ones. The first ones I'm going to go through are the trig functions. So I'm going to put a comment here. I'm going to use 15 in the brackets as my angle for all of these functions, just so you can see how they differ using the same number. If I do sine of 15, I get this value. I can do the same thing with cos, or the same thing with tan. So sine 15, cos of 15, or tan of 15 is going to give me different values. By default, MATLAB takes the 15 and uses it in radians. So if you wanted to use 15 degrees, you would have to do sine d, cos d, or tan d of 15. And notice how the numbers are different. Sine of 15 is 0.6503, and sine d of 15 is 0.2588. Similarly for cos and tan. Now if we want to take the inverse of sine, cos, or tan. When we do inverse, it is the same as putting arc before the sine, cos, or tan. So we can have arc sine, which is the inverse of sine, arc cos, which is the inverse of cos, and arc tan, which is the inverse of tan. The functions that we use for these are a sine, again I'm going to use 15, a cos 15, and a tan 15. Again, these numbers are in radians. If I want to find the inverse of 15 degrees for each of these trig functions, I need to put a sine d, a cos d, or a tan d. Now let's look at exponents. In general, if I want to do exponents, for example, 2 to the power of 3, I have to use this on my keyboard to signify exponent. 2 to the 3 is 8, or for example, 5 to the power of 2, it's 25. But if I want to do the e to the x exponential function, I'm going to do exp. So for example, if I have e to the power of 2, it's not going to work because e is not a predefined value in MATLAB. So in order to use the exponential function, we actually have to do exp bracket 2, and that does e to the power of 2. Or we can do exp of any other value to use the exponential function. Now for the square root function. The square root function uses this syntax, sqrt of x, and we can put any number in for x. So for example, the square root of 45, and we will get our value. Or the square root of 36, we get 6. Now let's talk about the natural log. Natural log is more commonly seen as ln, and to do this, we cannot just type in ln of x. So if I want to find the ln of 2, I can't just type in ln bracket 2. ln is not defined in MATLAB, and it won't know what you're talking about. To use ln, we actually have to put log into MATLAB with the number next to it. So log of 2 gives me the answer to ln of 2. If I wanted to use common log, well, common log has a base of 10, just like natural log has a base of e. For example, if I wanted to find the common log of 2, I can't do log of 2 because remember, log actually does ln. You need to use log 10 of your number. So say I want to find the common log of 2, I do log 10 of 2, and then I get the value. So remember the difference between log 10, which is the common log with a base of 10, and just log, which is our natural log with a base of e, which is ln. Now let's do the absolute value function. Just like the square root and exponential and logarithmic functions, you've probably covered the absolute value function in earlier math courses. So remember that absolute value functions take in any value and return only the positive value. To use the absolute value function, you type ABS and put the number you want to take the absolute value of in the brackets for x. Say I want the absolute value of 2. Well, that would just be 2, because MATLAB will take the positive value for whatever number you put in. If you put a positive number in, you are going to get the same number back. If you put a negative number in, for example, -2, you will get the positive portion of it back. So you would get 2 as your output. Or if I have -5, I would get +5 as my output. But if I just have 5, my output will be just 5. Now we're going to talk about finding the maximum and minimum values. So to do this, we just use max bracket or min bracket. So you will note that I have these round brackets with the square brackets in between them. We are going to create an array. An array is just basically a set of numbers. To find the maximum or minimum number in a set of numbers, we will use these functions, max or min. For example, say I want to find the maximum value of 1, 2, 3, 4, or 5. I have to put the 1, 2, 3, 4, 5 within square brackets to create the array, and then right outside I need to have them surrounded by these regular brackets. So it will give me the maximum value is 5. Now if I do the same thing, but just put min instead of max, the minimum value is 1. I can take the maximum value of any set of numbers. For example, the maximum here would be 25. But if I do the same thing with min, I get 2 because the minimum number in this set is 2. So it has to be more than one number that you're putting in the array so that MATLAB can find the minimum or the maximum number out of a set. Now let's talk about rounding functions. So MATLAB does 3 things. You can either round up, round down, or you can round in general. Rounding in general means if the decimal is 0.5 or above, you round up. Otherwise, you round down. So let's look at the 3 functions MATLAB uses to round. We have ceil, which stands for ceiling of x. X is going to be the number we want to round, so 123.45. Ceil, and I always remember that as ceiling, means that it rounds up. So it will round to the next nearest integer, which is 124. But in contrast, if we put the same number with the function floor, it rounds down. So we round down to the nearest integer, which is 123. So now if I just use the function round, and then I put our value, this will round in general. So if the numbers right here after the decimal are 0.5 or above, it will round up. Otherwise, it will round down. So 0.45 is less than 0.5. So this should round down to the nearest integer, which is 123. And that's what it does when we hit enter. So these are the 3 different functions MATLAB uses for rounding. Now let's look at the function to find the remainder after division. If I want to divide 2 numbers, for example, 24 divided by 5. 5 will go into 24 4 times. 5, 10, 15, then 20. But you will have a remainder of 4. How do we get MATLAB to give us the remainder? We have to use the rem function. Within the brackets, you're going to put 2 numbers. The number on the top is going to be the x. The number on the bottom of your division statement is going to be the y. So remainder of 24, 5 means you're doing 24 divided by 5 and finding the remainder. And the answer is 4, which is what it should be. So the next one I'm going to talk about is finding the phase angle. So if you have a mathematical expression, we can find the phase angle, where x is in radians by default. So all we do is angle of x. And say, for example, x is 3 plus 2i, a complex number. So this would be the phase angle. You can also use regular numbers. You would get the phase angle for those as well, but it's more commonly useful for imaginary numbers. And next is finding a complex conjugate. You need a complex number to begin with in order to use this function, but all we do is conj of x, and x is going to be our complex number. So for example, I can do conjugate of 2 plus 3 times I. And from earlier math courses, the complex conjugate is just the opposite sign right here. Instead of a plus, it would be a minus. 2 minus 3i instead of 2 plus 3i would be the complex conjugate. If I do it with a number that's not complex, like 3, you're not going to get anything different because it's not a complex number to begin with. For example, if I just take the conjugate of like the square root of 3 plus 2, you're going to get the same value back. The square root of 3 plus 2 is 3.73. And if I put it in the conj function, I get 3.73. So it didn't really do anything differently. It only works if you have a complex number that has I in it to begin with. Now I want to discuss some predefined constants in MATLAB. So the first one is pi. If I type in pi, I get 3.1416. Although the number for pi is a lot longer than that, MATLAB has defined it as this. So if I want to use pi in a function, for example, if I want to say pi times 3, I don't have to be typing in 3.1416 times 3 each time. All I have to do is type in pi and MATLAB knows what that is. Next, if I type in I, MATLAB also knows what I is. I is an imaginary number, and it will give you a complex number when you type in I. You might have learned complex numbers in an earlier math course, but complex numbers always have two parts to them. The real part, which is where an actual integer number will go, and in this case it's 0, plus the imaginary part, where you have a number attached to an I. So this entire part becomes imaginary or complex. This part becomes complex. So this part becomes the imaginary part, and if you hit I, MATLAB knows that you have one I. So if you hit I, MATLAB knows that you have one I. So it gives you a 1 in this imaginary part of the complex number. The next one is inf. This means infinity. So MATLAB, when you type in inf by itself, but this is defined as infinity. So if you had to use it, you just type in INF, because you can't really draw the infinity symbol in MATLAB, but it can be useful for other mathematical calculations. And the last one I want to talk about is NaN, with 2 capital N's. So this signifies not a number. Again, MATLAB doesn't do anything when you type it in directly, but you can use it in other equations. So if you have other complex numbers or numbers that are not real, like 0 over 0, infinity over infinity, sometimes in your output code, MATLAB will tell you NaN, which means this is not a number. For example, if I just type in 0 over 0, I get NaN, so MATLAB tells me this is not a real defined number. So that was all I wanted to talk about today. If this lesson helped you, please give it a thumbs up and subscribe to my channel for more related content. I'm going to be leaving a link in the description below to the related blog post, so everything that I just talked about is explained in that post in writing. So if you'd like to have that lesson plan, head over to the link in the description below. Thanks for watching.